So when we have a variable, we have two methods that we can use. We can use our exact same method that we used for numbers, where we draw a factor tree and then group things out. So if, for example, you look at the square root of x to the ninth, if you were to draw a factor tree for x to the ninth, that means that you have x repeated 9 times. So 1, 2, 3, 4, 5, 6, 7, 8, 9 times. So just like we do with numbers, what we would do is we would group by the index. So the index of a square root is understood to be 2. So I would say, okay, here I have 2 x's, so that's going to be one copy outside of my radical. So I will write down that one copy. Then I say, okay, I have another group of 2 x's, so that's another copy outside the radical. Another group of 2 x's, another copy outside the radical. Another group of 2 x's, another copy outside of the radical. Now, what's left over is this x. So that is going to go inside of the radical as just an x. Now, just like what we did over here with our 4 square root of 32, when we had 4 times 2 times 2, we multiplied all those together. So the same thing is going to happen here. We're going to have to multiply x times x times x times x. And remember, when you multiply exponential terms, you add their exponents. So what will happen is all of these x's, when I add their exponents, will become x to the 4th, and then I'll still have the square root of x. So that will be our final answer, x to the 4th square root of x. Now, there's nothing wrong with going through this method. The issue is that if the exponent gets really large, it's kind of like you're writing out all these x's and then circling a bunch of x's, and it can get kind of tedious. So another way of doing this is you can divide to find the exponents. So instead of writing out all the x's, what I could do is I could have started with the square root of x to the ninth, and I could say, okay, the index is 2, so I'll take 9 divided by 2. So it's almost like that little index sign becomes a division sign, and we have 9 inside, just like it's inside this radical here, and 2 outside of the division sign, just like it's outside of the radical sign. So what you would do is you would take on your calculator 9 divided by 2, and you get 4.5. So that tells you that 4 is your starting point for your quotient. So you take 4 times 2, and that gives you 8. You then subtract, and you get 1. Now, 1 into 2 is not going to go evenly, so that means that we have a remainder of 1. Another way of thinking about this is the remainder here is smaller than this 2, and so that tells us then that we are done. So this is smaller than our 2, our divisor, and so we are finished. That is our remainder. Now, here is what we do. We take this top line, this 4 remainder 1, and that top line becomes the powers that will be on x. So this is going to tell us that the power outside of the radical is going to be 4. So we have x to the 4th. And this tells us that the remainder is going to be x to the 1st inside of the radical. But again, it's all about telling us the power. So it's telling us 4 is the power on x outside, and that inside of the radical, we have a remainder of 1. So this tells us what is inside of the radical. So those are our two methods. We can either go through and factor and then group, or we can divide to find the exponents when we are dealing with variables.